complex cube roots of negative root 3 plus 1i. Alright, so where are we going to start with this? Well, if you look at the bottom right corner of your screen, this is the theorem that gives your roots for a complex number. Now if it's cube roots, there's going to be 3 of them, right? That's the first thing we need to realize. There's exactly 3 cube roots for any complex number. So we got to find all 3 of them, right? Our answer will have 3 answers. So if you look at this theorem down here, we'll get into it in a little bit, but the first thing you have to realize is that it's given in terms of the polar version of the complex number. Okay, so the first thing we have to do is change this complex number into that's in rectangular form right now to polar form. Okay, so we've done this a bunch of times before in the previous sections. That's the first thing I'm going to do is just convert it. Remember how we're doing this. We could use r equals the square root of x squared plus y squared, but we recognize this as a special triangle, so I'm going to draw a picture. Okay, I want the distance from here to here, that's r. If this side is 1 and this side is root 3. Okay. So I recognize this is the smaller angle because it's opposite the smaller side, so that's a 30-degree angle. So this angle then would be, has to be 150 degrees, right? If that's 30, it's 180 half turn, then that's got to be 150. So there's my theta value, and I'm going to leave this in degrees. And now all I need to do is find r, which we can pretty easily find. I could do the square root of x squared plus y squared, but I don't need to do that because I know that this is a 30, 60, 90 triangle. That side 1, that side root 3. So r, of course, would be 2. Okay, so now I can write my complex number in polar form. I'm going to call it w. Okay, call my complex number w, and the roots will be z sub k. Okay, for k equals 0, 1, 2. We'll get to that in a second. But right now, let's just write our complex number in polar form. 2 times the cosine of the angle, 150 degrees, plus I times the sine of the angle, 150 degrees. Okay, that's the first step, convert to polar form. Same point, this, or same number, that number, same number. Okay, so now I'm going to take the roots using this theorem down here. And remember, just what we're trying to accomplish here, I'm going to have 3 of them, right? K will be 0, 1, and 2. So I'm just going to come down here. These are going to be my answers, just to kind of give us a little guidance. Right? And remember the idea here. We're taking cube roots. So that means if I cube any one of these answers, I should get the number that I'm starting with. Right? If you take the cube root of this, then I'm going to get 3 answers for that. When I cube them, raise them to the 3rd power, I should get that. Okay, so something to keep in mind. So we'll go ahead and apply the theorem, and then we'll take it from there. Okay, so I'm going to copy down the theorem and fill in what I know. That is, my roots are given by, okay, so the first part, the nth root of r. So we're taking cube roots, that's the cube root of r, and for our example, r is 2. Okay, cosine. Alright, so let's see, theta sub 0, what does that mean? Well, that's my angle for the number I'm taking the cube root of. Okay, divided by n, 3 roots, plus 2k pi, we're using angles here, so that's 360 times k, same thing, divided by 3. Okay, this is going to give me my 3 different angles, alright, plus I sine, and I'm going to leave this blank to save myself some trouble because the same thing goes in there. That is the same thing here, 150 degrees over 3 plus 360 degrees k over 3 goes in there. Okay, I'm just saving myself the room. And you can do that too, I don't mind. So, simplify. 150 divided by 3 is 50 degrees. And I'm going to be adding to that 50 degrees 120 degrees. Plus I sine, and same thing goes in there. Okay? Alright, moving on. So now, this is the formula that I'll use to get my three answers. Okay, so now I'm going to start with my answers down here at the left. Z sub 0 is going to take k to be 0, right? That's what these are. This is k0, k1, k2. So my first answer, oh, I made a mistake. Let me jump back. That should be 2. Fix that. That's a 2. Sorry about that. Okay, so my first answer is the cube root of 2 times the cosine of 50 degrees plus 120 times 0, right, which is 0. So that's my first angle. And this one I'll write completely. It's 50 degrees. So there's my first root. The 1 cube root of this number here is given by z sub 0, right? If I were to cube that, remember De Moivre's theorem, if I were to cube that, what do you get? Well, you raise this to the third power, gives you 2. And what you do with these, you multiply them each by 3, which of course would give you the 150. Okay, so there's my first answer. Now the second two come pretty easily. All you have to do is add 120 degrees to the angle, right? So that's going to be cosine of 170 plus I sine of the same angle, 170 degrees. Okay, and finally our third root that we called z sub 2, the cube root of 2 times the cosine of, add another 120 to that angle, and you're going to get 290. Okay, and there's my answers. If I cube any one of those answers, I'm going to get 150 degrees. So you might be thinking, well, if I multiply 170 by 3, it doesn't give me 150, but it will give you an angle that's coterminal with 150. And then we can just subtract 360 from that, and you should be in the same place. So you can check those. Multiply each of those angles by 3, and what are you going to get? An angle that's in the same place as 150. All right. So try and remember that process. It's a little lengthy. And keep doing your homework. Keep practice.